Hello kids, you are going to learn the unit 5 of grade 9 syllabus. The lesson is pressure exerted by solids. So dear kids, you can refer this lesson from page number 60 to page number 71 in part 1 science textbook. So in this lesson, you are learning about pressure, the factors affecting the pressure and the units of pressure, as well as changing the factors affecting the pressure as we need it. After the lesson is done, you should be able to understand and explain the concepts of pressure. And you should be able to explain the factors affecting the pressure, as well as you should be able to obtain the units of pressure. And you should be able to change the factors affecting the pressure as needed. Finally, you should be able to carry out some simple experiments in order to explain the factors affecting for the pressure. Okay kids, before step into the lesson, just tell me, you have used a school bag with a narrower strip one day and you have used a school bag to bring the same amount of books which has a broader strip in another day. So, in which occasion was it very comfortable to you to carry the bag? Yes, your answer is when the strip is more broader. So, now please look at two kids on the screen. The boy looks very tired. The girl looks very fine, right? So, what is the reason for this? Though the strip is narrow or broad, the force exerted by the weight of the school bag is the same, right? But when the strap of the bag is narrow, the contact area is less, and when it is broad, that area is more. So now it is very clear, my kids, when we have two school bags of equal weight, the force acts on shoulders remains same. But the pressure against the shoulders differs with the contact area. It means broader or narrow way of the strap. At the same time, you need to observe this also. When two bags have the straps of the same breadth and different weights, the more weight gives more pressure. So now you have an idea about pressure. The force exerted over a unit area is known as pressure. So here you can take two main things, the force and the unit area. So the definition of pressure is the force exerted over a unit area. It is known as pressure. So to define this concept of pressure, dear kids, we need two factors. They are the perpendicular force and the surface area on which the force is acting. You can see here I have used F for force and A for surface area. P symbolizes pressure. So look at the first figure which is in your left hand side. You can see the unit area is below and the force of the object, it means the weight of the objects gives a pressure on the surface. It is up to the unit area which is contacting the surface. So here, go to the figure of your right hand side. I have given you A, the area as 1 square meter and the force acts is 1 Newton. So, to find pressure in the same place, we can use the sum pressure equal force over area. Force is 1 Newton and the area is 1 square meter. So, the answer is Pascal, 1 Pascal. So, what is this Pascal? Pascal is the scientist who discovered this concept, who did so many experiments on this, and he is the one who introduced this concept to the field of physics. So his name was given to symbolize the international standard unit of pressure, that is Pascal. So the SI unit of pressure is Pascal. You can see another unit is also there, that is Newton per square meter, Nm-2. So you know my kids, there are two units for the pressure. One is Pascal, that is the standard unit, SI unit. The other is Nm-2. Okay, so 1 Pascal is equal to 1 Nm-2. So lower you can see 1 kilopascal is equal to 1000 Pascal. Always kilo means 1000. Okay. Okay Pute, shall we apply the things we have learned so far? Now we have the sum P equal F over A. It means the pressure equals perpendicular force over contact area. Okay, so look at the first one. What is the weight of a rock that has an area of 10 square meter and that exerts a pressure of 250 Pascal? Here you have given the pressure as well as the area. So the thing you need to find is the force, right? So shall we apply? You know, 1 Pascal equals to 1 Newton per square meter. So the Pascal can be converted into Nm-2 and you can directly write 250 Nm-2. So apply it and the final answer is there as 2500 Newton. Okay. In the second one, you can see a student who wears 2 shoes. The student weighs 600 Newton. The student's shoes are in contact with the floor over a surface area of 0.012 square meter. Calculate the pressure exerted by the student on the floor. Here you have given the force and you have given the area. The thing you need to find is the pressure. So directly you can apply 600 Newton should be divided from 0.012 square meter. The answer comes as 50,000 Pascal. Okay, go to the third one. A box that weighs 250 Newton is at rest on the floor. If the pressure exerted by the box on the floor is 25,000 Pascal, over what area is the box in contact with the floor? The sum we have is P equal F over A. Okay, you have given the weight and you have given the pressure. The thing you need to find is area. Always when you are doing these kind of calculations, my kids, you need to apply the details you have with the units into the sum. Otherwise, there may be mistakes from our side. Okay. So, always when you are applying the things, apply them with the standard units. If they have given with square centimeter, you need to convert it into square meter. Okay. If they have given with Pascal, it's easy when you have converted into Nm-2. So, directly you can apply it into the sum and directly you can get the answer easily. Okay. Now we are going to learn about the factors affecting for pressure. Now Pute, you know there are 2 factors which are affecting for pressure. They are the perpendicular force acting on the surface and the surface area on which the force is acting. So in this experiment, we are going to learn about how the perpendicular force is acting for the pressure. So for this experiment, you need several cakes of soap, a thin metal wire, several bags of sand about weight of 10 Newton each, and a piece of plank which is longer than the length of the cake of soap and similar in breadth as the soap. And you need a stopwatch. Here you are going to do what? You are increasing the number of sand bags which are hanging on the strip, okay, hanging on the thin metal wire. Okay, so then first you need to place the cake of soap on the plank, which is kept on 2 tables as shown in the figure you can see. And first step, as the first, you need to hang one sandbag on the wire which is sent around the cake of soap, and please observe what happens. So as the second step, you need to increase the number of sandbags one by one using a new cake of soap in each instance, and you need to measure the time taken to pass this thin metal wire through the cake of soap, through each cake of soap. And you need to tabulate your readings, and you can see when we increase the number of bags which hang, okay, the time taken to pass is very less. It means when we are increasing the force on a same surface area, it means when we are increasing the force to it, it is a reason to increase the pressure. So in this experiment, you can get 2 conclusions. What are they? They are the force affects the pressure exerted on a solid object. It means the pressure depends on the force. What is the other one? Pressure increases with the increase of force. Okay, as the first we can get the idea that the force affects the pressure exerted on a solid surface. As the second one, we can get that pressure increases with the increase of force. Okay, now we are going to test the second factor on the pressure, that is surface area. For this experiment also you need a cake of soap, a piece of thin wire which the diameter of 0.2 millimeter, a piece of thick wire with the diameter of 1.5 millimeter, a sandbag of the weight of 20 Newton, a piece of plank which is similar in breadth to the cake of soap. So here, as the first step, you need to place the piece of plank between 2 tabletops and keep the cake of soap on the plank as shown in figure. Okay. Then send the thick wire around the cake of soap and hang the sandbag of 20 Newton weight, and please observe what happens. As the third step, you can remove the thick wire and repeat the activity by using the thin wire, and then observe what happens. So what is your idea? What can be concluded according to the observations that you have made so far? Okay, so here same weight is used in both instances. You did not change the weight, kids. But the thing you change is what? The area of the wire. Okay, we used a thin wire as well as we used a thick wire. Okay, so the force exerted on the cake of soap was same in both the instances. We changed only one factor, that is the surface area. Okay, so the pressure is greater when thin wire is used, you observed, and when we use a thick wire, it was less. So cutting through the cake of soap is very easier when we use the thin wire. So it means when we are reducing the surface area, the pressure is increasing. Okay, so now we have learnt 2 factors. The first one is perpendicular force. When we increase the perpendicular force, the pressure exerted on a unit area, on a place, is increased. But when we increase the surface area, what happens? The pressure becomes less. Okay. Next, we are going to discuss how we can change the factors affecting pressure as needed. Here you can see in the first figure, onions are cut by a knife. Okay. When the knife is well sharpened, it is very easy to cut the onions or whatever the thing we are cutting. The thing is, their knife edge becomes very thin when it is well sharpened, and because of that the surface area which is contacting with the object gets very low. Because of that the pressure becomes very high. So the object can be cut very easily. Look at the second instance. You can see a heavily loaded truck. Okay, this method is applied for container carriers also. Okay, so when they are run on the roads, what happens? Easily the roads can be damaged because of their very high weight. Okay, so to minimize the pressure exerted on the rod, they have increased the number of wheels on the truck. So the surface area is getting high. We know when the surface area is getting big, when the surface area is high, the pressure exerted on the surface is very less. So that is the point here. They have increased number of wheels. So the surface area is high. So the pressure exerted on the road is less. Look at the third one. It's up to skiers. Their skates are used with a sharp bottom. It's like a knife edge. So here, because of this, a high pressure is exerted on ice when the skier is skating. This high pressure makes the ice liquefy and form a slippery surface on ice. Okay, my kids, now we have come to the end of our lesson. Now you should be able to define the concept of pressure. What is the concept of pressure? The pressure is the perpendicular force which is acting on a unit surface area. And you should be able to explain the factors which affect for the solid pressure. What are the two factors? The perpendicular force and the surface area. And you should be able to calculate the amount of force should be applied on a particular area in order to create a pressure. Yes, we have done some calculations. What is the sum we used? P equal F over A. It means pressure equals perpendicular force over surface area. Next, you should be able to change the factors affecting pressure as needed. Okay, now this is the time to try these questions. I have extracted these two questions from your textbook, as well as there's a lot of questions in your textbook, and please refer those end of chapter questions. So it's the time to say goodbye. Thank you very much for listening and watching the video, and you can engage in more lessons in near future, as well as follow these links to get more idea about solid pressure. Goodbye, my kids.